everybody. Welcome back, boys and girls. It's your main math man, Mr. Strand, coming to you live from Walker Grant Middle School. And in this video, we're picking up where we left off with that real number system notes. And we're just kind of recapping, refreshing our memories, but also kind of working in some new ideas so that way we can better understand this concept. So to think back to the previous idea, we want to make sure we understand the difference between the whole numbers and the natural numbers. And so if you remember, we kind of closed with this last time, but we said that, that's not what I wanted to do. We said that the whole numbers include 0, but the natural numbers do not include 0. So again, a way to remember that is you could say the whole numbers have that little O in it, and so you can kind of remember that as the 0. So whole numbers have 0, natural numbers, the counting numbers, start at 1. And then it says, what two things must not happen for a number to be irrational? So again, kind of remember what we're saying when we say if a number is not rational, that means irrational. So just remember that key idea with that. So it must, the decimal form must not do two things. We have to say this, we have to say it must not end and it must not repeat. So it must do both of these to be not rational. So make sure that you're saying it, you have to check off both of these, that it does not do that for it to be not rational. So now, at the bottom of your page, if you want to, you can color it in. If not, that's okay too. But what I have here for you is similar to that diagram that we did, except now it has circles. Some people say it's an avocado, some people say it's an egg or an onion, whatever you want to call it. There's multiple layers inside of it. So make sure that you're seeing here first, and maybe you can try it out on your own. Maybe you write down some of these numbers or try to place them in these subsets for yourself. And so what I'm going to do first is I'm actually going to drag my labels to the correct spots. So make sure that you're labeling these subsets of the real number system correctly. So first we're going to say, alright, well, I know that the real numbers are going to be any of these numbers that are in here, and so that includes the entire set. So again, that's going to be that big area in green. Underneath that, my two main subsets, I'm going to say this is going to be my rationals. Let's put this right there. I'm going to have my rational here. I'm going to have my irrational all over by itself in its own little island. And the reason why I know that the irrationals are on that far right is because they're all by themselves. There's no subsets underneath the irrationals. So now underneath of the irrational numbers, we have the integers, we have the whole numbers, and lastly but never leastly, we have the natural numbers. So again, make sure you're seeing, again, they are, even though they are grouped inside of each other, they still have differences. So even though the natural numbers are also whole numbers, make sure you're saying that they are underneath of each other. So now what I'm going to do is I'm going to kind of pick randomly some of these real numbers that I have grouped out here. Again, as these are all real numbers because we are talking about them, we are including them in our course. And what I'm going to do is I'm going to place them in the most specific subset that they belong to. Again, let me repeat that. I'm going to place them in the most specific subset that they can go to. So what I'm going to do is I'm going to say, okay, well, they're starting out, they're all real numbers that I have here, but as I go along, I can kind of refine it and say more specifically what it is. The way you can think about it is, when we talked about your location, you said, okay, well, you start with, a city, you could have a state, you could have a country, a continent, so on and so forth. So you kind of want to have that. So let's just start real simple. Let's start with numero uno. So for number 1, what do we have? Well, we know, is that rational or irrational? Well, we know it's going to be a rational number, so we can have that there for now, but make sure you're just sticking with me because we might need to put that under a little bit further. So we're going to say rational. Is it on the number line, meaning is it an integer? We're going to say yes, it is. Is it a whole number, meaning is it positive? It is. Is it a counting number? Well, usually when I start counting, I start with this number specifically, and so I'm going to say that is most specifically a natural number. So make sure that you're seeing how that works. Now let's try something like, let's try a 0.7 or 70 cents. So I'm going to say, all right, well, it's in decimal form, and what did I say about my irrational numbers? Well, I said that for irrational, it has to not repeat and not end. Well, for this 0.7, does it repeat? It does not. However, it does end, and so it is rational. However, since it does have a decimal value, it is not an integer. So we can just place that in the rational numbers in here. So again, make sure that you're seeing where that is placed. Again, moving on. Can I have a negative number in the rational numbers? You better believe it. That decimal ends. What about the square root of 2? Well, we said that if it's a square root of a prime, it is going to be irrational. Again, if you need to check that decimal value, please do. It should be 1 point something, but the decimal form does not end and it does not repeat. Same thing, same idea actually for square root of 5. 5 is a prime number, and so the square root of that is going to be an irrational number. However, for negative 3, let's say it is a real number, it is rational, it is an integer. How about this one here? Let's go. We have 1.23, 233, 2333, dot, dot, dot. So again, does that, so kind of noticing what those 3 dots at the end, it does not end. However, does it repeat? Well, there are similar numbers for there. However, if you notice very carefully, again, make sure you're very observant for this. These are not repeating, meaning even though it's 2, 3, it would have to be 2, 3, 2, 3, 2, 3 over again. There's no pattern for this number, so make sure you're saying that this is irrational. That is not a rational number. So then for our next one, let's say 0. Well, we said that 0, we know since 0 is right where it needs to be, right next to the whole numbers, not in the natural. 1/2, that's a fraction, boom, right away, it's a ratio. Again, make sure you're seeing for the word fraction. Let me actually write that real quick. For the word fraction, if you notice what is inside the word fraction, yes, action is inside of there, but more importantly, you see RA and then TIO for ratio. So again, make sure that you are seeing that fractions are ratios. To move on past that, we have pi. That's a really easy one. It's going to be irrational. Square root of 36, well, that equals 6, which is a counting number. So again, make sure if you're able to just count that number positive, then it is a natural number. We have negative 0.9 is rational. We have a repeating number and 2.45 repeating. We have an integer and negative 8, a ratio from a fraction, and a terminating decimal. So you can make sure you're placing these in the correct subsets. If you need to pause, rewind, or replay, make sure you do. So now, on the back, make sure that you are seeing that you want to take those numbers, and you're going to say, all right, name the subsets to which each number belongs. You use the following letters to represent those subsets. And so we're going to say, instead of having to write out those huge words each time, we can say that we have R is going to be rational, we have IRR is irrational, I is an integer, W is whole number, and N is natural. So each of those letters stand for that specific subset. So make sure you're seeing each of those. To make it a little bit easier, let's pull a little sweet shank style for yourselves. And what I want you to do is, at the bottom or the side of your page, make a little diagram to help you remember that real number system. And so what I usually do, I usually draw this on the board, and you can draw it anywhere on paper, but you're going to have these letters RNS, that stands for that real number system. And I draw two little arrows outside of it. And I say, well, what do I have? I have that irrational numbers on the one side, and I have my rationals on the other. Underneath of that, again, those don't have to be big arrows, but just little tiny ones pointing to it. We have integers, whole numbers, and natural numbers. Again, if you're able to write that down for yourself anywhere on the page, it will help you vastly understand this idea. So please try it for yourself. Try these values out. I highly recommend that you first simplify. That way you can get your values carefully. So I'm actually going to help you with the first two, and then I will give you some time, and then we'll check it over. So let's see. So if we have negative 15, let's go back to that diagram, and let's actually write. Okay, I said let's get a nice blue color, maybe. There we go. I said, okay, if I have negative 15, how do I do this? So I know it's going to be a real number. However, is it rational or irrational? Well, I can put a check. I can say, all right, it is rational. It can be a ratio, and it is an integer. However, it is not a whole number. And why it's not a whole number? Because it's negative. And so we would say, okay, we stop there. So what we have to do now is we would say, okay, negative 15 is going to be rational and an integer. And so I'll show you what I mean there. So I'm going to say, okay, hey, this is going to be rational and an integer. And so what you can do is go along that diagram that you made for yourself and kind of check off the ones that you're seeing as they work out, and be able to say, okay, it is this subset because of a reason. Or you could say it is not this subset because of a reason. You want to make sure you're backing up your arguments with true facts. So I'll do one more. I'll do the second one. So it says, for number 2, it says 11. So let's say, let's get a different color in here. Say that. So it says, one more time, we said 11. Okay, so we know, all right, the decimal form is 11.0. That does end, so it is rational. Is it on the number line? You better believe it, so you can check that one off. Is it a whole number? Well, it's positive, so we're good. Can we count to it? You better believe it. So it is all 4 of those. So make sure you're including all 4. So we would say it is rational, it is an integer, it is a whole number, and it is natural. Again, make sure we're saying we have to say for each, let me actually say that one more time, name each of the subsets. So make sure you're saying it's each of those subsets that you have to label, and so we have to say for each of those subsets we're going to include it next to that value. So take some time, try it out for yourself, make sure you're using calculators for values that you need to simplify, and try it out for yourself. Again, make sure you try it out for yourself. Hit pause. Assuming you're coming back now, I'm going to go over these. So for these, what I did was I simplified first, and so for square root of 30, I got 5.47 ... and so the values keep going. Again, these squiggly lines mean approximately, and so there's no real pattern. It does not end, it does not repeat, and so we can say this is not rational, so we would say it's irrational. Right away for number 4, it's a fraction, so we know it is rational. Even though the decimal form it looks complicated, we know it is rational. For 6, again, that's a counting number, and so I can include all those subsets. It's rational, integer, whole, and natural. For 0, a little bit different. It's rational, integer, and a whole number. For negative 26 over 13, make sure you simplify, and we say that's equal to negative 2. And so, again, when I'm talking about this value, I have to make sure that I am referring to, I'm looking at this value. So I'm now looking at negative 2. Where would I, what subsets would I include negative 2 in? So I'd say it's rational and it is an integer. So be very careful when you are doing these. For number 8, it's a counting number, which means it is all 4 of those subsets. For number 9, it's a simple ratio, it's a simple fraction, it's rational. And for number 10, it is rational, integer, whole, and natural. Moving on after that, we have negative 13, and that's going to be rational and an integer. Pi, that's that go to irrational number. We have a very large number, but it is a ratio because it is a fraction. We have square root of 77. It's not a prime number. However, if you do get that decimal value, it does not end, it does not repeat, therefore it is not irrational. Since it's a fraction, already rational, then we can say square root of 0 is 0, and so we would say 0 is still that whole number, whole number, integer, and rational. Be very mindful when you are typing in your square roots, including a negative, make sure it is on the outside. And so what you can do first is you can say, well, I want to first evaluate the square root of 196, and you would say that is equal to 14, and then you would include the negative at the end. So we are saying this, the negative square root of 196 is negative 14, which is an integer and rational. Same thing for negative 1. For 19, we have it is equal to 8, and so that's all 4 of those. And for 20, we say that is equal to negative 45, which is an integer and a rational number. So again, make sure you're taking your time with these, rewind and replay. Be sure to use that diagram that I showed you and have that small diagram on the side. And as always, be sure to super slam that subscribe button.